Okay, so thanks to the organizers for including our paper in the program. Today I'm going to talk about the challenges and opportunities of using FinTech to fight climate change. And this is quoted with Alberto Rossi at Georgetown University. So I think we all agree that climate change is one of the most pressing challenges humanity is going to face in the near future. It's not surprising that governments around the world are implementing policies to reduce emissions from corporations. And while there is a debate about the optimal design and the effectiveness of these policies, much less is known on how to help individuals reduce their emissions. This is despite the fact they represent 30% of direct emissions, and so they are an important share if you want to reach the targets of the Paris Agreement. So why FinTech then? Well, FinTech represents a promising tool for at least two reasons. First of all, because due to the high penetration of technology, it can be deployed on a large scale, which is exactly what we need to solve such a problem like climate change. And also because there is plenty of evidence that FinTech can help individuals with their consumption, saving, and investment decisions. On the other hand, it's not clear whether those frictions that prevent optimal financial decision making are the same that prevent individuals from being more sustainable. So what do we do in this paper? In this paper, we partner with an Italian neobank that on top of the standard payment and deposit features also offers tools to monitor and manage emissions. More specifically, a footprint calculator, which displays footprint from card transactions, and a carbon offsetting program whereby by paying a fee, users join companies' effort in financing reforestation projects. So this was one of the first banks to introduce these tools, and many have followed, especially in Asia and in Europe. So which means that nowadays there are potentially millions of individuals exposed to these tools, and we don't know whether they have any effect on their sustainability. So what are the main benefits of our setting? First of all, we have a rich data set. We can observe the type of consumption, the amount of spending, and the category of spending through the MCC code, and most importantly, the CO2 emissions associated with each transaction. We have an identification strategy which exploits a marketing campaign run by the company, and we have a survey which we use to tease out the economic mechanism. So, as I was saying, what are these two tools? So the first tool is a carbon footprint calculator. So it costs about €2.50 per month, and it displays carbon emissions from card transactions. So imagine as a spending balance, right? Every time you log in on your bank account, you see how much you have spent in a given month. So it updates every time a transaction is approved, and it resets to zero at the end of each month. Now, this footprint calculator is provided by a third party, so it's called a company called Doconomy, which is an industry leader in this space. And so the footprint of a given transaction is simply the multiplication of the euro spent in that transaction and the carbon per euro associated with the merchant category code of that transaction. Because every time you swipe your debit or credit card, right, that transaction is associated to a merchant category code. And so the business of this third party is exactly this one. So to estimate the carbon per euro for each merchant category code. Now, obviously this measure is kind of noisy by construction, because ideally you would like to measure carbon footprint at the product level rather than at merchant category code level. But for what our purposes, what matters is that this is the state of technology nowadays, because measuring footprint at the product level is even more complicated. And also this is the same metric that other banks are using, because they all rely on this same third party. Now, the second tool is a full carbon offsetting program, whereby by paying a fee, you join the company efforts in financing reforestation projects. So what does it mean? That you pay a fee and then you get an offset, a carbon offset of 1,000 kilos per month. Now, based on our research, reforestation projects seems to be the most common way to perform voluntary carbon offsetting. And also in terms of the cost of offsetting this 1,000 kilo, there is a pretty large dispersion in the industry, but it seems to be in line with what we see in other providers. So, in the first part of the paper, we look at broad patterns in spending and emissions. So why this is important? This is important because we need to validate our data, right? Because when you spend 50 euros, right, in purchasing an item, there is no doubt that you spend like 50 euros. But the carbon emission associated with that 50 euros is ultimately, right, an estimate. And so we need to make sure that those estimates kind of align with common sense. And also because while there is a literature on how to make individuals more sustainable, right, this literature typically focuses on specific products in experimental setting. Much less is known when those decisions are made over the broad range of consumption categories and are made in the real field. So in the paper, we have 3 empirical exercises. In this presentation, I will only go through the first 2. So the first, we look at the concentration of spending and emissions across MCC codes. So, because what we want to make sure is that those individuals don't use the app just for a few type of transaction. So we want to make sure that what you observe is representative of their consumption. And also we look at the allocation of spending and emissions across consumption categories. So for this analysis, we aggregate merchant category codes into consumption categories, and we see basically where the users of the app spend and then emit. So first exercise, what we do, we take all individuals over the full sample, and for each individual, we look at the Herfindahl index of consumption and spending, right? So what does it mean? It means an Herfindahl index equal to 1 means that an individual would spend and or emit in just one merchant category code, while Herfindahl index equal to 0 means that the spending and emissions will be equally spread across all the merchant category code the users utilizes. And so what we do is, again, we look at the Herfindahl index for each individual, and then we plot the resulting cross-sectional distribution. And what we find that the average for spending is 0.09, for emissions is 0.15, so values very close to 0, so which means that, again, the average individual seems to allocate almost like equally spending and emissions across various MCC merchant category codes. For this analysis, we map merchant category codes, because there are hundreds of these codes, into consumption categories from the COICOP. So these are very similar to what you will find from the Bureau of Labor Statistics. And then again, for each individual, we use the full sample. We compute the share of spending and emissions across various consumption categories, and then display cross-sectional averages. So red dots refer to spending, while blue dots refer to emission. And we sort the x-axis based on the red dots. So in decreasing order based on the red dots, which denote share of spending. So what we find that recreation and food and beverages are the consumption categories that are the most popular, right? And they account for 40% of total spending. Then we have fast food, restaurant, hotels, clothing, and transportation, which together they account for another like 30%. And then all the other consumption categories have individually a share of 10% or less. Now, when we look at emissions, share of emissions, we see that for many consumption categories, they are pretty much aligned. But there are 2 main large deviations, for example, utilities and transportation. And why this is the case? Because when we look at the average carbon per euro of the MCC codes within this consumption category, what we find that utilities and transportation have the highest average carbon per euro, right, within these categories. And why this is the case? Because utilities comprises cooling and heating, which we know they have a high footprint, and transportation, right, comprises airlines, airline transportation, which again we know it has a higher footprint. So in the first part of the paper, we make sure that two things. What to observe is representative of the user consumption. So it means a user doesn't use the app just for a few merchant category code, and also that the type of information is displayed, right? So this carbon footprint seems to align with common sense or with like our expectations. Now, in the second part of the paper, we look at what is the causal effect of providing information on footprint, so basically providing access to this carbon calculator, and to provide carbon offsetting services. And we look at total spending, total emissions, right? Because if we want to fight climate change, we need to reduce emissions. And we also look at emissions per euro, because ideally, right, we would like to fight climate change not by depressing consumption, but by shifting consumption towards greener goods. Now, why this is challenging, like to find this causal effect, because the decision is obviously endogenous, so we cannot compare individuals who adopt the tool with those who don't, right, because there could be obviously be some selection bias, and we cannot compare the same individual before and after, because there could be reverse causality. So I might first decide to become more sustainable and then decide to adopt the tool. Now, what typically is done in this setting, typically researchers run diff in diff, right? Because when FinTech app introduce new tools, they do this through beta testing. So which means there's a period of time where a subset of the customers, the beta testers, receive this tool. Now, unfortunately, we cannot do this in our setting because these tools have been available in the app since the inception. But we still can get a causal effect using an instrumental variable. So how our setting works. So we exploit a marketing campaign that the company ran in July 2022. So we have our word before the encouragement, before the marketing campaign, where everybody has access to the tool. And then there is a word right after the marketing campaign, and we have a control group that doesn't receive any notification, right? It's not subject to this marketing campaign. And then we have a treated group, an intervention group that receives this encouragement, those push notifications, those emails. And so if those are effective, we should observe a higher adoption in the treated group as opposed to the control group. Again, there could still be adoption in the control group simply because, right, the tool is available to everybody. It's not like a beta testing where this tool is only available to a group. Now, so in this sense, we are not inventing anything new here. So this type of identification strategy is common, especially in the econ literature. And what is the idea here? The idea here is to strip out the endogeneity coming from the adoption of the tool and only use the variation which is driven by this encouragement. So what do we have? We have our first stage. We have a dummy equal to 1 if user I subscribes the tool at time t. We have user fixed effect, time fixed effect, and this dummy, which is equal to 1 for those who are encouraged for the treated group, right, during the marketing campaign. And then we have the second stage, right, where we have our consumption, spending per euro, user fixed effect, time fixed effect, and then the endogenous variable, right, if a user has adopted the tool, instrumented by this encouraged. And so what we are after is this beta, right, which tells us the difference between the change before and after in the treated group compared to the control group. So it's essentially, it's a diff in diff, but it's an instrumented diff in diff. Now, which means, right, because we are using an instrumental variable, that we need to satisfy three assumptions in order, right, this to be to claim causality. First of all, right, the instrument has to be exogenous. This is the case in our setting because the company selected this group randomly, and in the paper we show that this is indeed the case because the characteristics of the treated and the control group are balanced. We need exclusion restriction, so which means that this marketing campaign had an effect on our left-hand variable only through the adoption of the tool. And this seems to hold in our setting because obviously if it was so simple, right, to change behavior by just sending email or by just sending push notification, we would already solved, right, this climate change problem. But what we do, we also look at those who are targeted by the marketing campaign and didn't adopt the tool, and we find that they don't seem to change their behavior. And finally, we need the relevance. And so these are the results from the first stage specification, right? So we need to make sure that if our instrument is relevant, it indeed drives adoption. So these are the results from the carbon calculator, and these are the results for the carbon offsetting. So what we find that for the treated group, so those who were targeted by the marketing campaign, the adoption rate is higher by 2.6 percentage point, which in relative terms, right, is huge because in the control group, right, the adoption was 2.8. So which means that in the treated group, the adoption was 5.4%, right? So almost double. And so we have the same when we look at the carbon offsetting, right? So those who were targeted by this campaign, the adoption was close to 1%, which is small in absolute term, but in relative terms is still very large because again, it's almost double compared to the treated, so to the control group. So, which brings us to the two main results of the paper. So what is the effect of providing information about your footprint, right? So when we started the project, we sit down and thought, okay, what could happen here? No? So if we give users information about their footprint, well, there could be a positive effect in terms of sustainability. Right, based on the literature on FinTech, that shows that providing information on spending helps individuals to be like reduce overspending. You might think, well, if I give you information on your footprint, right, this could help you to better manage, right, your footprint, and so we could observe a reduction in your, an increase in your sustainability. However, this hinges on the fact that individuals are able to understand this information, are able to act on this information, that this information is precise. So if not, right, one could even expect a null effect. There could be even a perverse effect whereby individuals fail to realize that this only covers car transaction. And so, right, they see a number, says, okay, my footprint is 500 kilos per month, and they think this number is very low, and so then, right, they feel the kind of license to pollute more. So what we find, if anything, we find no effect. If anything, we find even like a large increase in consumption, but no effect on emissions and no statistical effect on emissions per euro. So what does it mean? It means that providing information on footprint, right, doesn't seem to change the behavior of those individuals. So what about the carbon footprint? So the carbon offsetting program, right? Also here, there are three possible scenarios. And remember, carbon offsetting program means that you pay a fee and then you receive an allowance of 1,000 kilo per month, right? So what could happen? Could happen that individuals don't change their behavior, so they still consume, right, as they were doing before the adoption of the tool. If this was the case, we will still observe a drop in their emissions, so a positive effect on their sustainability, which is purely driven by this allowance, right? Because you pay this 9 euros per month, and then you get this 1,000 kilo allowance. It could also happen that individuals, after adopting this tool, right? They reduce their consumption, they reduce their emissions, and so this will then we will observe an even larger effect, right? Because there is a double effect driven both by their reduction in emission and this allowance. But also here there could be a sort of a perverse effect, and this is what researchers have found, for example, in medicine. When we talk about statin pills or pills for cholesterol, so those who take those pills for cholesterol, because, right, they think, well, I have the pill, took the pill, so the pill lowers my cholesterol, then what happened? They engage even more in the behavior they shouldn't, right, follow, like eating fat food if you have cholesterol. And so there could be the same effect here, right? You pay a fee, you feel licensed to pollute and to be less sustainable. And if you do this above, right, the allowance, then this could make you even, could have a negative effect on your sustainability. So what we find, our results seems to be in line with the first scenario. So we find no effect on consumption. So individuals don't seem to change their spending. They don't seem to change their kind of spending habit. But there is a huge effect on emissions and emissions per euro, right? So the effect is close to 100%. So 100% reduction in emissions. Why this is the case? This is because the 1,000 kilo allowance is pretty large and almost covers their entire emissions, right? So basically it's a purely mechanical effect. People don't change their behavior, but this allowance make the footprint drop. So from this paper we have two main results. Individuals seem to be more likely to adopt the carbon footprint, right? Because the adoption rate was higher, much higher compared to the carbon offsetting, but the carbon footprint doesn't change behavior. And then we have the second result, that individuals are less likely to adopt the carbon offsetting, but this has a huge effect on their behavior, right? So not on their behavior, it has a huge effect on their sustainability, which is mechanical. So we want to understand why. We want to understand why individuals don't change behavior after adopting the footprint and why individuals don't adopt the carbon offsetting program. So, and what we do then, we ask them directly, right? So we run a survey. The survey has 3 sections. In the first section, we ask whether they have ever used the carbon footprint, the carbon calculator, depending on whether the answer is yes or no, we ask them to assign a score to a set of motives that we offer to them. So we do this for the carbon calculator, carbon offsetting, and then we elicit their beliefs about climate change, whether they think climate change is important, is an urgent problem, whether they think they could do something, right, to fight climate change, and also we elicit their understanding, their literacy about climate change. So these are the results, right, for those who adopted the carbon calculator, right? So for these individuals, we want to understand why they didn't change their behavior. Now, we reject the information channel. So why this is the case? Because individuals seem to agree with the statement that they understand how the information is computed, the information is accurate, they think the information is new and is easy to reach. So the average of the responses are well above 3, which corresponds to neither agree nor disagree, so the neutral stand. So we reject the information channel. For those who adopted the carbon calculator, we also ask whether they think they become more or less sustainable. And for those who tell us that they think they became less sustainable, we reject the constraint channel. So we fail to reject the constraint channel because the average of the responses to the motives, well, being sustainable is costly, or I already do what I can, right, to be sustainable, I cannot do more, is, right, not statistically different from 3, which is again means neutral stand. While for those instead who think they've become more sustainable, we find support for the idea that giving a carbon footprint helps them monitoring what they are doing, and also it's something that is motivating, right? A little bit like the Apple Watch that shows you, right, your number of steps, number of calories. So being able to monitor and also give you some motivation. These are the results instead for those who did not adopt the carbon offsetting program, right? So we want to understand why. And our results seems to be line the two main channels is because these guys want trees to be planted in Italy rather than in South America. So because these reforestation projects are run in South America. So that seems to be the first main reason. And also it seems to be a sort of limited attention problem. So individuals, they don't seem to be aware of this service. What we reject instead, so these individuals, is not that they don't adopt the carbon offsetting because they are not interested in sustainability or because they think that planting trees is not effective. In terms of the cost, or in terms of like MEA emissions are already low, right? So they are already doing the best. Though the average of those distribution is 3, which is, so it's not statistically different from 3. So again, which means we cannot say much about these two channels. And so, as I said, we also ask about what they think about climate change. And here is the most probably interesting part of the survey, because when we ask in absolute term, right, do you think climate change is important, is an urgent problem, right? Everybody, so most of the users seems to agree that this is a very important, this is a very urgent problem. And also when we ask them, do you think, right, you can do something to fight climate change? So do you think that your action have an impact on climate change? Right, 70% of the individuals strongly agree with this idea that yes, what I do has an effect, right? Which is not obvious. Why it's not obvious? Because we are talking about Italy. And in reality, even if all Italians, right, would drop their emissions to 0, this would have no effect on the fight of climate change, because obviously countries like India, China, and US have a much higher impact. So, but still, like 70% of individuals tells us, yes, I think that what I do has an impact. And this is close to what I think is the impact of governments, corporations, and previous generations. But when we ask in relative terms if they think climate change is important, relative to other economic problems Italy is facing, like immigration, low growth, unemployment, only 30% of the individuals tells us that climate change is more important, right? So close to half of them, and like another 20%, think that climate change is as important and or even like less important. So when we ask in absolute term, everybody thinks that climate change is important. We ask in relative terms, well, different pictures emerges. And also, when we ask about their support of policies, they seems to be against policies like tax on flights, tax on gas, those policies where they have to pay the cost, right? So directly have to pay the cost, while they are strongly in favor of policies where the cost, right, is bared by, for example, corporations or others, right? So what is the picture that emerges here is that individuals seem to care about climate change, but not enough, right, to do something. And it seems that they are not willing to bear like directly the cost. So last minute, let me wrap up here. So we know that climate change is a very important problem. There is a lot of attention on how to reduce emissions from corporations. Much less is known on how to reduce emissions from individuals, even though they still represent an important share. Why we think FinTech can help, right, or at least is a promising tool, because due to the high penetration of technology, it can be deployed on a large scale. What are our main finding? We find that individuals seems likely to purchase these to get access to this carbon calculator, so which means they are willing to learn about their footprint, but they don't seem to change their behavior in response to this. A much smaller fraction of individuals are willing to pay to offset their transactions, so they're willing to subscribe to carbon offsetting programs. This has a huge effect simply because it's a mechanical effect. Individuals don't change their behavior, so the effect is purely mechanical. From the survey, we seem to have a sort of a subtle mechanism here. So individuals seem to care about climate change, but not enough, and they are not willing, right, to directly bear the cost to solve, to become more sustainable. And this is everything from me.